Welcome to Ziba Academy. In this tutorial we learn how to create game, using Rust programming language. This is the project structure. Now create files and folders. Cargo.toml file. src. Assets. Each code will be explained with a subtitle. In Rust programming, the main.rs file is the entry point of a binary crate, containing the main function that is executed when the program runs. In Rust game development, files named projectile.rs, alien.rs, player.rs, and game.rs typically represent individual modules that define the behavior and properties of game entities and the overall game logic. Projectile.rs might handle the movement, collision detection, and rendering of projectiles like bullets or missiles. Alien.rs could define enemy characters, their behaviors, and interactions. Player.rs would contain the player's character, controls, and state management. Game.rs usually serves as the main game loop, coordinating the interactions among all entities, managing game states, and handling rendering. These modular files help organize code efficiently, making the game easier to develop, maintain, and extend. This code loads an alien sprite texture using asset_server.load alien.png, and then spawns a grid of alien entities across the game screen. It iterates over X and Y coordinates within the defined width and height, calculating each alien's position based on grid spacing, and adjusting for screen resolution to center the grid vertically. The position is computed by creating a vec3 for each alien, offsetting it to center the grid horizontally and vertically, and applying the resolution's pixel ratio for proper scaling. For each position, it spawns an entity with a sprite bundle that includes the transformed position and scaled sprite, as well as an alien component that stores the original position and a dead flag. This setup visually arranges aliens in a grid pattern on the screen, ready for interaction or movement in the game. This code snippet defines parameters for a bevy system, including commands for spawning or despawning entities, alien_query to access all entities with the alien component along with their entity IDs, alien_manager as a mutable resource managing alien behavior and states, resolution as a resource providing screen dimensions and pixel scaling, and time to access timing information such as delta time between frames. This code iterates over all alien entities with their components, updating their positions and states each frame. It moves each alien horizontally based on the elapsed time, the current direction stored in alien_manager, and a speed constant. If an alien moves beyond the horizontal boundary of the screen, it signals the alien_manager to shift all aliens downward and calculates the distance from the boundary for further processing. If an alien is marked as dead, it is removed from the game by inserting a dead component and its visibility is set to hidden, otherwise, it remains visible. Additionally, if any alien moves past the bottom of the screen, the game sets a reset flag in alien_manager, likely to restart or reset the game state. manages the behavior of aliens in a game, specifically handling their movement when they reach screen boundaries and resetting their positions. When shift_aliens_down is true, it resets this flag, reverses the alien's horizontal direction, and shifts all aliens horizontally by the distance from the boundary while moving them downward by a fixed amount. If alien_manager.reset is true, it resets this flag, sets the direction to right, and restores all aliens to their original positions stored in alien.original_position. Additionally, if any alien was marked as dead, it clears the dead status and removes the dead component, effectively reviving them for a new game round. The setup_player function initializes the player entity in a game by spawning a sprite with the player.png texture, positioning it at the bottom center of the screen based on screen resolution and pixel ratio, and scaling it appropriately. It also attaches a player component with an initial shoot_timer of 0, enabling the game to manage the player's shooting cooldown. The function uses bevies commands to spawn the entity, loads assets via the asset server, and accesses screen resolution data through a resource, ensuring the player appears correctly positioned and scaled within the game window. The update_player function is designed to handle the player's behavior during the game loop by accessing and modifying relevant components and resources. It queries for entities with both player and transform components, allowing it to update the player's position or state. It also receives the time resource to manage time-dependent actions, such as cooldowns or movement, and the button input key code resource to detect player inputs like movement or shooting commands. The function also accesses screen resolution data to ensure any positional adjustments are correctly scaled and positioned within the game window. Overall, this setup prepares the function to process input, update the player's state, and handle timing-related mechanics during each game update cycle. It updates the player's position based on keyboard input. It retrieves the single player and transform components, then checks if the or D keys are pressed to move the player left or right accordingly, scaled by the elapsed time and a speed constant. It enforces screen bounds to prevent the player from moving off screen by clamping the X position within left and right limits derived from the screen dimensions. The player's shoot_timer decreases each frame, and if the spacebar is pressed and the cooldown has elapsed, it resets the timer and spawns a bullet entity at the player's current position, scaled by the pixel ratio, with a projectile component that defines its speed. This logic facilitates smooth player movement and shooting with cooldown management. This Rust code defines a Bevy plugin called Resolution plugin that sets up screen resolution information at startup. The plugin adds a system setup _ resolution to run before startup, which queries the primary window to obtain its width and height, then creates and inserts a resolution resource containing the window's dimensions as a vec2 and a pixel ratio set to 1.0. This allows other parts of the Bevy app to access consistent screen resolution data.